Hello everyone, and welcome back to the Fluctus Channel. A giant ship does not simply disappear when its working life ends. After decades at sea, carrying oil, containers, passengers, vehicles, or bulk cargo, it may make one final voyage to a ship-breaking yard, where workers dismantle it by hand, torch, crane, cable, and patience. Shipbreaking yards are the final factories of the maritime world. They recover thousands of smaller parts from vessels that are too old, damaged, inefficient, or expensive to keep operating. Every year, hundreds of ocean-going ships are sold for recycling, while new vessels continue entering the global fleet. Causes of scrapping include age, corrosion, fuel inefficiency, accident damage, market downturns, and new environmental rules that make older ships less profitable. South Asian yards in Bangladesh, India, and Pakistan have long handled many of the world's largest beached vessels, while Turkey, China, and other countries also play major roles in controlled ship recycling. The work creates valuable raw material, but it also raises serious safety and environmental questions because old ships may contain asbestos, fuel residues, heavy metals, paint toxins, oils, and contaminated sludge. Commissioning a ship for scrapping begins with a commercial decision. The owner sells the vessel, often based on lightweight steel tonnage. Brokers, recycling yards, flag states, and cash buyers may be involved before the ship reaches its final beach or dock. Before cutting begins, workers inspect spaces, identify hazardous materials, remove loose equipment, drain liquids, and plan the sequence of dismantling. A beach yard depends heavily on tides. The ship is driven or pulled as high as possible onto the shore during high tide. When the water falls, workers gain access to the hull. Timing matters because cutting, pulling, and hauling must follow the sea's rhythm. The tools are direct and physical. Workers use gas torches, winches, chains, hammers, forklifts, excavators, cranes, cutting lines, and transport trucks. Inside the ship, the day begins by stripping cabins, galley spaces, engine rooms, wiring, insulation, furniture, doors, pipes, motors, and fittings. Small teams move through dark compartments where each item must be removed before larger steel sections can be cut. Ventilation, gas testing, fire control, and lighting become critical because enclosed spaces can hide fumes or flammable residues. On the exterior, cutters divide the hull into sections. Plates are marked, heated, sliced, and pulled away. Large pieces crash or are lowered under control, then cut again into smaller sizes that can be handled by machines or carried to trucks. Heavy engines, shafts, anchors, propellers, and deck equipment may be separated for resale or melting. The work looks rough, but it follows a sequence. Remove hazards, strip reusable items, open access, cut upper structures, reduce the hull, and clear scrap from the beach. Regulations shape how safe this process should be. Responsible recycling requires inventories of hazardous materials, worker protection, waste handling, fire prevention, and environmental controls. Toxic materials must be isolated, removed, and disposed of properly rather than dumped into sand or water. Steel from the ship then enters the market as scrap, feeding furnaces, rolling mills, construction supply chains, and manufacturing. The old vessel becomes beams, bars, plates, and raw material for new industry. Shipbreaking is therefore both an ending and a beginning, a dangerous dismantling process that turns an ocean giant into the metal bones of future machines. By the end of a working shift, pieces that once formed decks, cabins, and engine spaces are sorted by grade, weighed, loaded, and sent onward, giving the yard its daily income each day. Submarine scrapping follows a very different rhythm from beach ship breaking. A submarine is not simply a steel shell. It is a military vessel built with pressure hulls, classified equipment, thick structures, and, in nuclear-powered boats, reactor systems that require special disposal. In the United States, nuclear ship and submarine recycling is centered at Puget Sound Naval Shipyard and Intermediate Maintenance Facility in Bremerton, Washington, where the Navy has handled inactivation, reactor compartment disposal, and recycling under controlled industrial conditions. The process begins after the submarine is decommissioned. Weapons, sensitive equipment, fluids, batteries, reusable machinery, and classified systems are removed or secured. For nuclear-powered submarines, the reactor is defueled before recycling reaches the heavy cutting stage. This step separates the fuel handling process from the later dismantling of the hull, allowing workers to focus on removing and packaging the reactor compartment safely. Cutting a submarine requires planning because the hull was built to resist pressure. Workers mark sections, set up containment, prepare torches and cutting equipment, and remove internal structures that block access. The submarine is divided into major pieces. Forward and aft sections can be separated from the reactor compartment. Open ends are prepared and sealed, while each section is handled under strict procedures. Hull section removal is a major lift. Cruise position supports, check balance, attach rigging, and coordinate with crane operators. A large section that once carried sailors beneath the ocean now moves slowly through the shipyard air. The motion is careful because the steel is heavy, awkward, and often surrounded by other equipment. Workers use radios, hand signals, taglines, and spotters to keep the section stable. Cranes then move pieces of the dismantled submarine towards storage, transport, or further cutting. Smaller sections may be reduced for scrap after sensitive material is removed. Reactor compartments are sealed and prepared for shipment to approved disposal sites, while non-radioactive metal can enter recycling streams. Compared with beach scrapping, submarine disposal is slower, more regulated, and more technical. The goal is not speed. It is control, security, environmental safety, and the careful retirement of a vessel built for one of the most demanding missions at sea. Shipyard workers also document each stage because the disposal trail must prove that radioactive material, classified systems, and ordinary scrap followed the correct path from dry dock to final destination without shortcuts. From start to finish, without confusion or costly rework, every time. The aircraft version of a ship-breaking yard sits in the desert. At Davis-Monthan Air Force Base in Arizona, the 309th Aerospace Maintenance and Regeneration Group, known as AMARG, operates the world's largest military aircraft storage and preservation facility. Across about 2,600 acres, thousands of aircraft and engines can be stored, preserved, stripped for parts, regenerated, or eventually scrapped. The dry climate and hard desert soil make the location ideal because corrosion slows and aircraft can be parked without sinking into soft ground. For many aircraft, the boneyard begins with a final flight. A C-130 or fighter may land under its own power, taxi in, and shut down after years of service. From that moment, the aircraft enters a new process. Crews inspect records, drain fuel, remove explosive items, disconnect batteries, protect sensitive equipment, and decide its storage category. Some aircraft are kept for possible future use. Others become parts sources. Some are prepared for museums, foreign partners, testing, or disposal. Preservation is detailed work. Openings are sealed. Tires, canopies, intakes, exhausts, and access points are protected. Spraylat coating is applied over windows, seams, and sensitive areas to reflect sunlight, keep temperatures down, and prevent dust and moisture from entering. The white coating gives many parked aircraft their distinctive desert appearance. Workers treat the aircraft not as junk, but as a resource that may still support the force. Boneyard operations run like a massive inventory system. Aircraft are arranged by type and condition. Parts are removed when active units need them. Engines, landing gear, avionics, panels, and structural pieces may return to service elsewhere. If an aircraft reaches the end of useful value, crews begin scrapping. Panels are removed, components are recovered, and the airframe is cut or crushed in controlled stages. Like shipbreaking, aircraft scrapping turns an old machine into parts, lessons, and recycled metal. This is why the boneyard is not only a graveyard, it is a warehouse, maintenance center, museum source, parts bank, and recycling yard. All spread across the Arizona desert, where yesterday's aircraft can still solve tomorrow's problems. For crews across the force, not every machine in the boneyard is waiting to be destroyed. Some are waiting for a second life. Aircraft regeneration takes a stored airframe, inspects it, repairs it, replaces missing parts, tests systems, and returns it to flight or mission. At AMARG, this work can turn a silent aircraft in the desert into a useful asset again. The regeneration process begins with selection. Crews review the aircraft's condition, hours, maintenance history, corrosion level, and mission needs. An F-16 regeneration shows the scale of the work. Maintainers clean the airframe, service systems, install components, test fuel and electrical circuits, and run engines under controlled conditions. Functional checks follow, proving that controls move correctly, instruments respond, brakes work, and the aircraft can taxi safely. A functional check flight is the final proof. The pilot takes the regenerated aircraft into the air, tests handling and performance, and returns with data for maintainers. Some regenerated F-16S become QF-16 aerial targets, flying without pilots to support weapons testing. Other aircraft or helicopters may be prepared for transfer, training, or allied support. Mi-17 helicopters moved from storage for transport to Europe show how a boneyard can support wider security needs without new production. This completes the life cycle story. A ship-breaking yard cuts old vessels into marketable steel. A submarine yard retires undersea warships through controlled disposal. A morgue preserves aircraft in the desert, then either scraps them or regenerates them for another mission. Behind every ending is a workforce turning worn-out metal into safety, spare parts, or raw material. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. Thank you.